Alright, this video is going to go over the mole and mass relationship. So hopefully by this point you have already completed the intro to the mole activity. If you haven't, I want you to stop this video, complete the intro to the mole to help your understanding with this particular portion. So what the intro to the mole activity did was it showed you the mass of 1 mole of some different elements. I had the mass of a mole of aluminum and sulfur and copper, and just to show you how much was in a mole. And it wasn't that much. But you should have noticed that they didn't have the same quantity, it looked like, because some had very small amounts, some had larger amounts, gross appearance-wise. And they didn't have the same mass. You would have noticed that in the video. But they all contained 1 mole of that particular substance. Now, I obviously did not count out by hand 6.02 times 10 to the 23 atoms of copper and 6.02 times 10 to the 23 atoms of tin. I would probably be dead by now if I did that. So what I would have to do is have a relationship between the mole and the mass so that I can actually quantify how much I'm working with. And so you should have noticed that sulfur was actually heavier than 1 mole of aluminum. You would have noticed that tin was heavier than 1 mole of iron. And the reason why it was heavier was because, I'm going to try to change this and see if it's a little bit, was because on the periodic table, sulfur has a larger mass than aluminum. Tin has a larger mass than iron. So the mass of 1 mole of a substance is equivalent to its molar mass. We call it a molar mass, the mass of 1 mole of that substance. So we're going to look at the atomic mass on the periodic table and use that to determine the mass of 1 mole of each of those elements. And we're going to do our conversions in much the same way that we did it with the atoms, but this time we're going to use that molar mass. So again, we always start by writing our given. So we start by writing 3.32 moles of K. Then we're going to set up our conversion factor so this unit goes at the bottom. So we put moles of K down here. And what number are we going to put with moles? Well, 1 always goes with moles. So we put that here. This time we're finding grams, so we want grams up on the top. And in order to find the grams of K, you look at your periodic table, look at its atomic mass, and that's going to be the mass of 1 mole of K. So 1 mole of K is equal to 39.1 grams of K. Then I plug this into my calculator. No fancy stuff here. And I'm going to show you what I get. I get 129.812 grams of K. Now here's the problem. I'm supposed to have 3 sig figs. When I try to round this to 3 sig figs, I get 130, which actually only has 2 sig figs. So you can fix this one of 2 ways. Way number 1, which I don't like, but I will accept, is just putting a decimal point right there. Leaving it like that, 130 decimal point, to make that 0 significant. That's not technically correct, but it's the easier way. I will accept it. The better way is to move this into scientific notation, put that 0 to make it significant, and that would be the proper way to express that number to 3 significant digits. Okay? Now in this next example, find the number of moles in 187 grams of aluminum. So you start by writing what was given, 187 grams of aluminum, times, remember, whatever unit we're starting with, that unit goes down here at the bottom. You use your periodic table to find your grams, so that's 26.98 grams of aluminum, and we know that 26.98 grams of aluminum is equal to 1 mole of aluminum up here. Notice I always put my units at the bottom first, and then figure out which number goes with it, because the units are what's telling me what to do. Then I take 187, and I'm going to divide it by 26.98, because the 26.98 is in the bottom. Every time the number's in the bottom, I divide. If it's in the top, I multiply. I need to have 3 sig figs because of the 187, so I will record my answer as 6.93 moles of aluminum. Alright, I will go over the multi-step problems in the next video.